Singaporean scientists think mass production of superworm intestines may be a nature-based solution to Southeast Asia's plastic waste problem. They studied the creatures to find out how exactly they were able to digest plastic. Could worms be the answer to plastic pollution? This is what researchers at Nanyang Technological University (NTU) in Singapore hope to achieve. They already know that the worm's gut microbiome can break down waste at a molecular level, and can be altered to break down plastic more effectively. Now, they want to know how this natural mechanism can be exploited on an industrial scale. The protagonists of the study are worms that you can buy almost anywhere in Singapore, said Lu Yinan, a researcher from NTU who worked on the project. We bought the super worms from a local pet shop. These super worms are very famous because they can eat and break down plastic, Lu Yinan told the Associated Press. Previous research showed these nutritious super worms are dark-colored insect larvae, scientifically known as Zophobas atratus, have bacteria in their guts that enable them to break down ordinary plastic. However, the use of worms in plastic processing is impractical. It is difficult to maintain large populations of worms, which naturally consume plastic, and quickly evolve into non-plastic eating insects. That's why scientists at the Singapore Bioenvironmental Sciences Engineering Center at NTU are trying to eliminate the middleman in this process, or in this case, the superworms. They wanted to find a way to artificially gut the plastic-consuming worms. After the worms finished eating the plastic, they made holes. We then removed the microorganisms from the worms' intestines and put them in bottles containing fresh plastic. So, in the end they started to grow and break them down, said another researcher named Saksham Barolia. Hundreds of worms are divided into 3 groups. For a month, 2 experimental groups were given food made from plastic, especially polyethylene, polypropylene and polystyrene, which are commonly used in styrofoam and plastic bags. Using a petri dish, one group of worms is fed oatmeal or cereal grains. This research is one of only a few in this area that looks at the interactions of microorganisms and plastic in the marine environment. The ultimate goal is to develop new bioprocesses so they can better manage plastic waste, said Associate Professor Sao Bin, who led the research. This plastic waste is a major environmental problem in Southeast Asia, where plastic pollutes marine and freshwater ecosystems throughout the Asia-Pacific region. A 2020 report from the UN Center for Regional Development estimates that the amount of plastic waste entering the ocean from the Asia-Pacific region will range from 2.3 to 6.4 million tons by 2030. At the National Museum of Singapore, a new Plastic 101 Feet exhibition seeks to raise awareness of how society can reduce their use of single-use plastic and increase their daily recycling habits. However, with more than 50% of the world's plastic produced in the Asia-Pacific region, Sao Bin said the only way to incentivize companies and countries to invest in recycling is to recycle plastic into materials that can generate profits. This is where super worms come into play. The next step for these researchers is to better understand what remains after the gut biome breaks down plastic and whether this remains can be monetized, as well as whether this entire process can be scaled up. Sao Bin said, the process can be a series of reactions to convert plastic materials into monomers, or relatively small molecules, which can be converted into something more valuable, continued Sao Bin. From takeaway food containers to rubbish bags, single-use plastic is common in Singapore, as in most Southeast Asian countries. We have a big plastic problem and we need sustainable methods to solve the problem. We can look to nature, including super worms, and learn from nature, learn how worms, how microbes, break down plastic, said Chris Rinke, microbiologist who once led research on super worms at the University of Queensland, in Australia. Then we can use this method at an industrial level and hopefully this will help recycle large amounts of plastic, he added. Chris Rinke, who is now a professor at the University of Innsbruck in Austria, said that while he believes there is no panacea for the plastic waste problem in Southeast Asia, he said, super worms could be part of a nature-based solution, which could be used to tackle the problem. To overcome the plastic waste crisis, we have to use less plastic. We also need to switch to products that are more environmentally friendly, such as coffee cups that can be reused many times, said Chris Rinke. Apart from that, we need to increase recycling efforts, and for that we can use super worms. This natural method uses superworms, microbes and their enzymes to recycle plastic, he added. The next stage of the research is to investigate the possibility of creating gut microbes in vitro or fertilizing externally, without worms.